Okay, so in this part, we're gonna make this spider web beautiful once and for all. So let's start right away. We are taking our main threads. We're getting the across threads. The interstrips, we don't have it because we just have one geometry. And we're taking the curve attract and the curve repel, merging it all together. And because of the curves, we're having like this weird display because it finds a width attribute here. But when we clean it and we're only keeping the class attributes, we only have, the geometry. And this is what it looks like. So not much for the moment, but the next node is gonna help us a lot. I'm gonna show you what it does. So as you can see, it changes a lot the aesthetic of it, and we can definitely see some interesting patterns and holes in there and more organic, creepy uh, behaviors and look. That's why it's called Beautify, actually. So what we're doing is like taking the initial geometry, fusing it all together because we have like, 5 different geometries, separate geometries. We're converting this to lines just for good measure, and we're replicating a bunch of points. What we're doing is like we're replicating per point and keeping the input geometry, of course. We're replicating 5 points per points with that uniform scale and a bit of noise. And of course, keeping the source attributes if you want to keep the class attributes. We're connecting everything together within a search radius and giving that max search points. And we're blurring the position with the proximity type and without pinning border points, because every point will be considered as a border point, so nothing will move if we don't if we uncheck it. So yeah, we're just making sure that we don't have degenerate primitives and removed unused points, just for good measure as well. And we're fusing everything back together again. So that's just what it is. It's not a lot, but it's definitely improving the shape, the look of it. And we're naming this the main threads because we would have other threads added on top of this. And I'm going to talk to you about the attached threads, which will be which sometimes I call them broken. I don't know. I should I should change this name once and for all. It's the broken threads. That's more descriptive of what they are. Because in the end, that's what it's gonna look like. We will have these threads which would be attached at one side would be at one point will be attached and the others will not. So when we will simulate them, they will fall, and they will entangle, and they will fall beneath not beneath, but they will fall down, and you would have this more organic feeling that the spider web was there a long time ago, and you would have like broken threads. So what we're doing is like randomly attributing some point count onto our initial geometry, deleting 100 points, actually 101 points. You can take more if you want, of course, giving them an ID value and giving them a normal attributes randomly generated like inside a sphere, so it can point at in every direction. And what we're doing here is like the new method of doing a copy stamp. Before we used to have like a copy stamp. We don't have it anymore, and this is the new way of doing it. So what we're doing is like taking the point attribute ID that we're creating on the for each begin. The for each begin will just like take 1 point at a time, um, and yeah, so we are operating on that and creating a line with different length based on the attribute ID and fit between 1 and 3. And we're copying it to that point and doing that for every point. And you know, every line has a different length. And yeah, so you can make it more, you know, drastic. And sorry, I changed something, but it's not supposed to be changed. Yeah. We just need 2 points for the moment, but we're resampling after. We can make it more drastically different. You know, you have like really small and really big. So yeah. And we are resampling it, cleaning the attributes that we don't want, and setting the group as broken. And now we have like these two types of threads. And there will be a third one. Actually, this one I'm gonna talk about it right now. You will find it in my file, but I'm not gonna take the time to explain it because actually it's from another tutorial that I will link in the description, but it's used to create Spider-Man threads, kind of Spider-Man threads. So that would be a waste of time for me to talk about it, and I don't want to, um, you know, it's not my work. I just changed a little bit of stuff here and there to especially here to adapt it to my setup and make it more procedural. But I'm sure that if you just like follow the tutorial of I think it was in Houdini Hive. I don't remember the name of the guy, but I would definitely link it into the description. Yeah, it will be easy to understand what I did here. So yeah, you will end up with these kind of threads, which will be attached to the initial geometry that initial collision geometry that we gave. So yeah, I'm not gonna use that because we don't need to, but just bear in mind that you can still have these kind of cool threads. So yeah, let's wrap up this video for the moment, and next one would be the last video probably, and we're gonna simulate it once and for all and see how it looks like.